we are going to find the area of the outer loop of this polar equation. What do you mean by outer loop? Well, I'm glad you asked. What we're going to do is figure out how this thing would graph if we were to graph it. I just sort of traced it with my fingers just a little bit. There we go. And then we'll sort of talk about what's going on. Not sort of talk about it. We are going to talk about it. Let's plug in a value of 0 for theta. If I plug in 0 for theta, then that would be an angle in standard position, and I want to know how far out to go. Is it 0? Is it this 1? Is it 3? Plug in a 0. 1 plus 2 times the cosine of 0. Cosine of 0 is 1, so 1 plus 2 is 3. That is where it starts. And then you graph. I'm going to do as much as I can without a calculator. Then you'd graph, and it would swing around, and then it would swing back. Whoa, I wonder where that is. And then it would loop back around, and then it would come back here. So bare minimum, you know this is happening, right? Because we're dealing with the area of something in polar form. Something. There we go. We know that much, right? So let's actually color, terrible colorer, but let's color what's going on. And it's going to be this stuff right here, but not this inner loop. It's like the Death Star that got smashed in one little section. Anyway, it's fully operational battle station. Sorry, Return of the Jedi. Here we go. I want to know where this thing starts and where it stops. And this is going to be a little bit tricky. So let's just go ahead and start with what we do know for sure. It starts at 0. Okay? Well, it starts at 0, and then it's going to come around, come around, come around, come around, come around, and come around. And then I want to know where that is. Well, where is that? Well, you could say the origin if you're talking in rectangular, like XY mode. Or you could say, well, if I'm sitting right here, then whatever the angle was, my radius was 0. We have moved out from the origin 0 units. So the radius would be 0. So let's find where this radius is equal to 0. We'll do a little bit of solve here. So -1/2. Everywhere cosine is -1/2, and that is going to give me values of 2 pi over 3 and 4 pi over 3. So here's what happens. If we were to graph this by hand, we would start here, it would swing around, and we would get 2 pi over 3. Now, stopping there would give us just that portion of the graph. Let's just go with that. Let's build a strategy here. Because if you keep going, then you got some other stuff, and like you're going to find the area of all this, and then the area of that, and then the area of that again, and then the area of this. Okay, let's be careful how you're taking your angle around here, because things can get crazy. Again, doing this gives you this area. I think that's a really good starting point. Now, if you're thinking, well, that's too much, you don't need to count that. I hear you. I'm with you. But 2 pi over 3. Just to confirm, let's grab a calculator. And we're going to graph it. I already have it typed in. And we're going to press window, and let's adjust some things. I was tinkering with some stuff, and trying to go down and clear. I can't. 0, now I can. 2 pi over 3, and graph it. That's it. That's what I say that's what I'm looking for. It's not what I'm looking for. That's a little bit too much of what I'm looking for, because now I need to figure out where interval theta values is this empty space. So we have way too much, and now we need to subtract some empty space. Well, let's also be honest with the thing that's happening in your head right now, and you're like, well, that's fantastic, but don't I need the whole thing? Yeah, you do. Double it when you're done. Okay, so this 1/2 is really going to turn into a 1. I'm about to, in a few minutes, I'm going to put a 2 in the front and be like, oh, and we got 2 pieces, right? That's what's going to happen. But next, let's find out this area right here. And let's be real honest with ourselves. We could treat it like it's this area also. So this loop occurs from 2 pi over 3 to 4 pi over 3, right? So from 2 pi over 3 to 4 pi over 3, we have a loop. If you did that whole thing, you'd have the whole loop, and you don't want the whole loop, you really just want half of it. So half, because it's part of the formula from the notes, and you've seen the notes, it's this half, okay? And then we're going to deal with just half of this. So let's just figure out what interval we're dealing with. Let's go for the obvious first. 1 plus 2 cosine theta. And again, we're subtracting because we would find all this and then be like, oh wait, I don't want that part. So we're subtracting that. And then d theta there. All right, let's find out where this is. And we can experiment on our calculator. I'm actually going to go ahead and tell you a little bit of what the thought process is that will guide us in our experimentation. 0 degrees, 0 radians, I should say. Sorry, we're in calculus. Pi over 2. 2 pi over 3 takes me back to the origin. 4 pi over 3. 2 pi over 3, 4 pi over 3. Halfway in between 2 pi over 3 and 4 pi over 3, the average of these two would be an angle of pi. At an angle of pi, you would have a radius. I would go out this way, but technically the radius is going to be -1. So we'd be facing this direction, but we would back up 1. So if you want to get all technical about it, you could find where the radius, which is this formula, you don't have to do this, you could find where it's equal to -1. And if your mind goes there, that's fine. You'd subtract 1, divide by 2, you'd get -1, and this would give you pi. Now, again, logic will dictate to you that halfway in between these two is pi. So what I'm going to do, I'm going to use the top half to be consistent with what we're actually finding. Whole area here of the top minus this little piece, which would start at pi, an angle of pi and a radius of -1, and end at 4 pi over 3. And I'm going to write it and then I'm going to confirm it on the calculator. So pi and then 4 pi over 3. And we'll do that. So window, pi, and then 4 pi over 3. And yep, that's it. That's the piece. And so we're going to do that, and we're going to figure all this stuff out. But again, I said this earlier, the 1/2 comes from the formula. Just that's the way it is because of what was explained at the very beginning of this video. It was lovely. However, when you find this, you found what was shaded up here in these top 2 quadrants, but I want the whole thing. So we're going to double it. Now, clearly looking ahead, those would cancel, so don't even type anything. So let's start typing things. Well, do type things, just don't type the 2 times a half. That's just pointless. So math, 9, 0 to 2 pi over 3 of our radius squared d theta minus, math, 9, pi to 4 pi over 3 of our radius squared d theta. And once we do this, we should have an answer. And there it is, 8.338. That is our area.